Our presentation is about syntactic growth and reading effort in English to Japanese translation. So this can be paraphrased as an empirical reception study on linear translation, which is quantified by syntactic growth. This is a reception study because this is a study of readers of translation. And linear translation is one of the translation strategies. We believe that linear translation is very important, especially for English and Japanese language pairs. However, because you might not have heard of linear translation before, let me explain why we think this translation strategy is important. So first, let's look at the characteristics of linear and non-linear translation using a simple example. For example, suppose the source text is Tom bought a book that Mel read 2 years ago. If we translate it into Japanese in the normal way, in English to Japanese translation, the translation text would look like this. The subject, Tom, is at the beginning of the sentence, followed by the relative clause, which is shown in black, and the object book, and predicate by. We call this translation non-linear translation, or translation in non-linear way, because they are like crossing. And we think that there are two problems with non-linear translation. One is that the old information theme and new information rime in the target text are in a different order than in the source text, which may not preserve the equivalence of the reader's reading experience. In other words, the problem is that the information structure of the source text cannot be preserved in the target text. And another problem is that the main clause, Tom bought a book in this case, is split into two parts by the inserted relative clause, and the head of the sentence, I mean predicate, in this case by, appears at the end of the target text. So therefore, the reader of the target text has to retain more information in their working memory until the predicate is appeared. In other words, the syntactic structure of non-linear translation makes it difficult to read, resulting in higher cognitive effort in reading. So these problems can be solved by keeping the word order of the source text as unchanged as possible, which means translating linearly. We call this translation a linear translation. So as you see the bottom example, in linear translation, the old information and new information is translated in the same order as in the source text. Also, the main clause is not split into two parts. This means that we think the problem of difficulty in reading a non-linear translation can be solved with linear translation. So, however, to best of our knowledge, no empirical investigation of reception study for the reading effort of linear translation has been carried out. This study aims to test our hypothesis as to whether linear translation takes less cognitive effort in reading only target text than non-linear translation. So with this background, the question we try to clarify, or research question is the reading effort of linear translation lower than that of non-linear translation? So to answer this, I will first explain the metrics that define linear translation and non-linear translation. So in this study, linear translation is defined quantitatively. We use the idea of cross value, which quantifies differences in syntactic structure between the source text and the target text. If the word order of the source text and the target text are similar, the cross value is lower. Conversely, the more the word order of the source text and the target text differ, the higher the cross value. So we employ this idea. We defined linear translation, which has similar word order as source text, as a translation with low cross value, while non-linear translation as a translation with high cross value. So in the previous research, Okamura and Yamada have quantified linear translation in English to Japanese translation using the idea of cross value. So next, I will explain the metrics that define the reader's reading effort. The reader's reading effort is the cognitive effort of reading a linear translation or non-linear translation, which is measured by an eye tracker. So we use normalized total reading time on the target text. We call this NTRTT. According to Ogawa, NTRTT is calculated by dividing the total reading time on the target text, which is the total gaze fixation time, by the number of words in the target text. Longer reading time suggests a higher cognitive effort. In contrast, the shorter reading time indicates a lower cognitive effort. So in this study, the data was uploaded to the CRITT Translation Process Research Database, TPRDB, for analysis. So the calculation was based on the Cram total reading time on the target text, called TRTT, and the number of words in the target text, called TOKT, of the table automatically generated from the database. So to summarize so far, the research question can be paraphrased as is an NTRTT value, in other words, reading effort of a target text with a small cross value, in other words, linear translation, lower than that of a target text with a large cross value, in other words, non-linear translation. Also, it is important to note that the focus of our present study is on the case of reading only the translated text. So reading in this study means reading only the target text without the source text. Okay. So to answer this research question, we conducted an experiment in which we asked participants to read translated text while using an eye tracker. We recruited 15 participants who have relatively high command over Japanese like those who routinely read Japanese texts, regardless of their native language. The variable name that identified the participants is part. To prepare the experimental text, we collected general online news articles, newspaper articles that had already been translated into Japanese. We accepted 3 to 5 sentences, about 150 characters per text. For a particular sentence, we prepared 2 versions of translation, linear translation and nonlinear translation, by changing only the function words and the position of the content words. 4 sets of text were prepared, and 1 of the 4 texts was used for practice, and the other 3 texts were used for data collection. The variable name for the text is original text. So the experiment procedure is 4-step like here. First, explain the experiment's flow and the text outline displayed on the computer screen to the participants. After the eye trackers calibration and validation, display the target text on the screen. The order in which the text was displayed was randomized for each participant. After participants read the text, we conducted a comprehension test. A simple comprehension test in step 4 was conducted to secure the quality of each reading. Comprehension test consisted of 2 correct or incorrect questions about the content of the text. The test results were used in a statistical analysis as a 3-level categorical variable, hereafter referred to as a test. So 3 categories. 0 refers to no correct answer out of 2 questions, half to 1 correct answer, and 4 to 2 correct answers out of 2 questions. So to give you a general picture of the obtained data, here are some graphs showing the relationship between participants, text, and reading time. The y-axis of both graphs are NTRTT, which means readers' cognitive effort in this study. On figure 1, the left plot, x-axis refers to the 15 participants. For example, the participants named P08 tends to spend more time reading the target segments than like P05 or P12, P13, and P15, who read the target segments in relatively short time. The reading time differs among the participants, which should be considered in the statistical analysis. In figure 2 is a box plot showing NTRTT, cognitive effort for each text. The variable name, original text, on the x-axis refers to the text number, text 1, text 3, and text 5. These figures also show that reading time among the texts differ. So, because there is a considerable variation in the reading time depending on the participants, and the differences among the 3 experimental texts, for example, the differences in topics in each article affect the reading time, it may be difficult to see whether the difference between the linear and nonlinear translation affect the reading time. So, based on these results, we used linear mixed effects models. NTRTT, in this study, the reading effort, was the outcome variable. We included two variables, part as participant and original text, experimental text as random effect, which are reflected only in the intercept. The predictors were selected from several candidates like cross value, translation type, which is a categorical variable indicating whether the translation is linear or non-linear. The name is J Basashi. Variable name is J Basashi. This name is from Japanese. I will explain later. And also the results of comprehension test. And we also included other candidate variables like a Japanese readability score or fresh Kincaid grade of source text and so on as a candidate for combination of predictors. Then we compared the several models and selected the model with the lowest AIC score. So as a result, a model with a categorical variable indicating whether the translation is linear or non-linear, and results of comprehension test as predictors was selected. So it might be a bit confusing, but here J versus G means linear versus non-linear. So these J and G are actually from Japanese, and J means linear translation and G means non-linear translation. And the table 2 and figure 3 summarizes the model. So first, from the top part of the table, the reading time for the non-linear translation here, second line, was significantly longer than that of the linear translation for the participants who answered both questions correctly on the comprehension test. And second, among participants who read the linear translation, those who answered both questions correctly on the comprehension test, who got full score, had significantly longer reading times than those who answered non-correctly. So the results of this model are plotted here. The left plot shows that reading time tends to be shorter for the linear translation than for the non-linear translation. The right plot indicates that participants who performed better on the comprehension test, which means those who read and understood the text well, tended to spend more time reading the target text. So these results suggest that linear translation requires less reading effort than non-linear translation. And the bottom part of table also indicates that random effects contribute significantly to this model. The intra-class correlation coefficient shows that 79% of the variance is explained by the random variables, suggesting that using a linear mixed effect model was appropriate. In addition, since conditional R square here is large compared to marginal R square score, so random effects contribute significantly to the model. So I will briefly summarize the findings again. Until now, there have been no empirical studies on whether linear translation in English to Japanese translation really reduce the effort for the reader. So we prepared linear and non-linear translations, asked readers to read them, and measured their cognitive effort. And from the data obtained, we analyzed whether linear translation or non-linear translation had a significant effect on reading time, taking into account the comprehension level of the text as predictors, as well as variations in reading time between participants and between texts as random effects. The results revealed that the type of translation, linear or non-linear, and the comprehension test results significantly impacted the reading time. Answering the research question, we can say that the reading effort of linear translation is lower than that of non-linear translation. So in addition to explain the reading time used as a measure of effort in this study, it is necessary to consider the type of translation, like linear and nonlinear, and also the comprehension of the text. This result may match our intuition that reading time is longer for those who read and understand the text well, but we realize that we need to improve the ecological validity of the experiment by fully specifying the purpose of the reading for participants. So one of the limitations of this study is the considerable variation in reading times across text. Even in the best model finally employed in this study, the random variables had higher explanatory power than the predictors. It is impossible to control the variation in participants' reading, but the texts used in the experiments must be reconsidered. Also, I would also be happy if this research provides a basis for introducing linear translation into translation training. So these are references, and I really appreciate your attendance, and thank you very much for your attention. Thank you.
Thank you, Takanori. And now we open floor for questions or comments. Anyone have any question or comment? Yes, yes, go to the mic, please.
Yeah, thank you, Takanori. What you describe as non-linear and linear translation to me seems to be the conversion between a hypotactic structure to a paratactic structure, right, where an embedded clause is transformed into a separate segments that are parallel to each other. And it makes sense. I mean, these, and also because the Japanese language had final structure for the relative clause, there must be a considerable extent of syntactic shift and reordering involved. So it should involve a large amount of effort when there is this shift, right? I was wondering, you were looking at from English to Japanese translation, and I suppose there must be a similar effect from Japanese to English. Did you look at that? And my second question is that the example you used, I bought a book that Mary read was a subject extracted relative clause, right? Because the relationship between read and the book was that the book was the Mary was the subject of read, right? I was thinking that if it's an object extracted relative clause, the parsing process would presumably be different because there might be some garden path involved. So did you look at different kinds of relative clause? So that's a bit long. So my questions are: one, did you look at Japanese to English translation? And two, did you look at other kinds of relative clause? Thank you.
Thank you for your question. So first question, I mean, we didn't have explained for the Japanese to English direction. So I don't have the data right now. Yeah, and the second question, it was what? I forgot.
Yes.
Yeah.
For example, if we, the example used here is I bought the book that Mary read, right? And if we have another example that goes, I saw the man that wrote the book, whereas the man wrote the book, it's a subject. The head noun is the object of wrote, right? And in this example, it's the subject of the verb. So I would say that when you translate that into Japanese, there would be some garden path effect involved. You would put the book before wrote, and that is after the subject. So you might say watashi wa hon o kaita, and then the head noun, right? But before encountering the head noun, it might be a sentence in itself. So there might be some garden pathing involved, right? I would say that this might be a different process, especially if you look at Japanese to English translation. Not really to say that this is a shortcoming, but I think it's very interesting to look at that. But of course, we need more detailed eye tracking data for that.
So for linear translation, I mean, what kind of source text structure it should be translated in linear way is still in the way of research. I mean, it's still difficult. Okay.
Maybe as a co-author, I think I should. I mean, it's an interesting point, and this is a garden path effect. This example, exactly what you explained. And also, we have other questions saying that did we have an experiment with non-translation? That costs more reading effort and stuff. I think what you're pointing out relates to just non-translation, but the reading effort, maybe more effort is required for the garden path sentence in a non-translated Japanese sentence. So I think, but the sentences we used for the experiment contained a variety of the sentences. So we did not restrict our the sample only for these cases. But I think we did not really divide the results. So I think that's a good, interesting point, and we need to elaborate more.
Yes, thank you, Masaru. I was thinking that the result might be the same when we look at other kinds of relative clause. It might be just the location within the sentence where extra processing effort is incurred would be different, but still we would expect more effort in that kind of sentence. That's what I suspect.
Yeah. Okay. Thank you.
Thank you.
So we have 3 questions in the chat. First question is, do you have similar effects when comparing linear and non-linear Japanese texts that are not translations? And I think Masaru talked about this. And the second question is, why did you normalize reading times by Moritz?
Because when we prepare the linear translation and non-linear translation, we change the function words and the position of the content word. And so if we change the function words, the word counts, number of words may be added or reduced. So we wanted to know the average value of the reading time divided by the word count. So we normalize that value.
So just a quick comment. Hello, I'm Haruka from Florida. So the term we use here, normalize, is not quite correct. I should probably say averaged. We averaged the values because the sentence length or the length of the relative clause is very different from sentence to, from text to text. So that's why. Thank you.
Thank you.
Thank you. And the last question from Elaine, thank you. Would you be able to explain how big is the difference in layman's term? How much does it impact the productivity of the Japanese translator?
I don't understand the layman's terms.
So can you explain in other words how much does this impact the productivity of the Japanese translators?
You mean?
Okay, here is your answer. They don't know. They didn't look at that. So thank you. Thank you, Masaru, and thank you all. You have a question? Sorry, we have one more question over here.
Hi, thank you for sharing your experiment with us, and it was really meaningful. I remember that you showed us a graph of how non-linear translation had a shorter reading time. Do you have a number on like how many % of reduction there was? That's my first question. And the second question is, what do you think is the reason behind the reduction of the reading effort? Because as a Japanese reader, a reader who reads in Japanese on a daily basis, the output of the linear translation is very natural, and you don't see the process of reordering. So the output that you're reading is very, it's natural Japanese. Do you think it's because the sentences are more simplified, or what do you think is the reason behind that reduction in the effort?
So the first question, I don't know how. I mean, the answer is like this. We have the value, the linear the reading time when they read linear translation and non-linear translation, and the difference is like this. Yeah, that answering your question.
I was wondering if there was a number that came out of that, like how much reduction there was. I'm thinking of the graph on the right. You had two graphs. There was the one on the right that showed that the reading effort reduced. I think it was before this.
We can calculate the number by average. But that statistical model doesn't really give you the percentage.
I see.
But we can calculate.
I see. Okay.
Further investigation is required, but one guess is maybe it has to do with the working memory retention. So yeah, that's yeah.
Okay, thank you so much.
Thank you.